Session 9, Working with Regions in Fluent Meshing. In this session, we discuss regions in Fluent Meshing software. As you know, the software has three types of regions: fluid, solid, and dead. For this session, we created a heatsink in Design Modeler software and selected named selections for the geometry. We then imported the geometry into Fluent Meshing and followed these steps: add local sizing, generate surface mesh, describe geometry. We describe the geometry as both fluid and solid. Update boundaries, and then go to the regions sections. After updating boundaries, we proceeded to the Create Regions section. Here, we face the setting Estimated Number of Fluid Regions set to 1, which means we have one fluid region. The Estimated Number of Fluid Regions parameter tells Fluent Meshing how many separate fluid volumes to expect in your geometry, helping with memory allocation and processing optimization. This value should be set to 1 for single continuous fluid domains like simple pipes or channels. At the same time, higher numbers are used for multiple separate fluid regions, such as a heat sink with shell and tube sides or multi-phase separators. For the question, do you want to retain dead region names? We set it to no and clicked Update. The Do you want to retain dead region names setting controls how Fluent handles isolated volumes that don't connect to boundaries. Setting this to no, recommended, removes these dead isolated regions for a cleaner mesh and faster processing, while setting it to yes keeps all regions visible for debugging and quality control purposes, which is particularly useful when troubleshooting complex geometries or identifying modeling issues. Next, we go to Update Regions, where we have several dead zones, a fluid zone, and a solid zone. Fluid zones represent areas where fluid flow occurs and are the primary regions of interest for CFD simulations, such as air flowing around an object or water through a pipe. Solid zones represent solid materials that may participate in heat transfer or act as flow obstructions, including walls, structural components, or heat exchanger tubes. Dead zones are isolated volumes that don't connect to any boundary conditions and cannot participate in the flow solution. These often result from geometry suppression, modeling choices, or gaps in the CAD geometry. While dead zones are typically removed for cleaner meshing, they can be converted to fluid or solid zones if needed for the simulation, and their identification helps ensure proper geometry preparation before mesh generation. We can go back to Design Modeler to see the geometry. The dead zones are areas we suppressed when we cut the geometry because these zones were subtracted. Fluent Meshing created dead zones from these suppressed areas. If we want to simulate these bodies, we can change them from dead to solid or fluid, and then click Update.
I hope this video is helpful for you. To benefit from Mr. CFD services, including simulation, consultation, and training, visit our website, www.mester-cfd.com. Contact us via info@signmester-cfd.com.